Hello students, welcome to the lecture on Database Management System concepts, and after this lecture we will be able to learn the following objectives. Understand the concepts of Database Management System, discuss about the entity relationship model, explain the three-schema architecture, define the DBMS languages and list all the advantages and disadvantages of using DBMS. Let's start with database concepts. Data is in contrast to information in raw or unorganized forms such as alphabets, numbers or symbols that refers to or represents conditions, ideas or objects. The term database, we usually mean a group of data that is stored on the basis of a system, which data do not necessarily get stored on a computer. Types of information handling. A database is a collection of the different phenomena that we are interested in an organized unit. Now let me tell you what are the types of information handling. We can store our data in different stocks and establish a connection between them with the help of a program. We can store our data in text mode also. This is the formulation of knowledge in a text-like way instead of a data-like form. We call the tool itself a text manager, and the text managing system is a database. Database administration. Database is a collection of data which stores the data required for a given task in an organized way, grants access to them, and at the same time safeguards the integrity of the units and protects them from any harm. Steps to perform mode-based database administration are: we create the entities along with their properties, we establish the relationship between them, the rest is dealt with by the database handler. Entity. We call the thing that's something that we want to describe with the help of our knowledge an entity. The specific entities are known as entity occurrences. As you can see in the figure here is the example of entity. Property. We call the thing that's something that we use to describe the phenomena which we are interested in a property. The concrete value of a property is the property value. The property value set is the term used for all the values present in a specific time. Both entity and property are relative terms. You can differentiate both as primary key, the property of an entity which takes up a different value for every entity occurrence is known as the atom or identifier of the entity. It is also known as primary key. We call the relation between the entities a relationship. Components of database systems. Data is a very important component of the database system. Data acts as a bridge between the machine parts, that is hardware, and software, and the users which directly access it or access it through some application programs. Data may be of different types. User data. It consists of tables of data called relations, where columns are called fields of attributes and rows are called records for tables. A relation must be structured properly. Metadata. A description of the structure of the database is known as metadata. It basically means data about data. System tables store the metadata, which includes number of tables and table names, number of fields and field names. Primary key fields. Application metadata. It stores the structure and format of queries, reports, and other applications components. Hardware. The hardware consists of the secondary storage devices such as magnetic disks, hard disk, zip disk, floppy disk, optical disks, CD-ROM, magnetic tapes, etc., on which data is stored together with the input-output devices, mouse, keyboard, printers, processors, main memory, etc., which are used for storing and retrieving the data in a fast and efficient manner. Software. The software part consists of DBMS, which acts as a bridge between the user and the database, or in other words, software that interacts with the user's application programs and database and file system of a particular storage media, hard disk, magnetic tapes, etc., to insert, update, delete, and retrieve data. Database engine. The database engine is the core service for storing, processing, and securing data. The database engine provides controlled access and rapid transaction processing to meet the requirements of the most demanding data consuming applications within your enterprise. Example, Microsoft SQL Server. Database user. Here are 4 different types of database users. Application programmers. A person who prepares application programs are called application programmer. Sophisticated users. Sophisticated users interact with the system without writing programs. Instead, they form their requests in a database query language. Specialized users. Some sophisticated users write specialized database application that does not fit into the traditional data processing framework. End users. Unsophisticated users interact with the system by invoking one of the permanent application programs that have been written previously. Thus, they are persons who use the information generated by a computer-based system. Database management system. Basically, it is a set of computer programs that controls maintenance and the use of a database. The database management systems are used for recording, storage, and management of the data in a database. The systems designed to make easier the management of the databases is called database management systems. We are familiar with Microsoft Access, which is also a database management system. We can use it to make new databases or add, delete, modify, or search for data in the already existing databases. Here you can see there are some main functions of the database management systems, which are: you can make new databases. Also, you can define the contents of the databases, make sure the data has been stored properly. You can query the required data. You can also protect the data as well. Moreover, you can secure the data. You have all the rights to access the data, but carefully. Easy to access. You can organize the physical data structures. Advantages and disadvantages of database. In this section, we will discuss about some advantages and disadvantages of database. Some of the advantages are: controlling redundancy, means repetition. Every user group maintains its own files for handling its data processing applications. Redundancy in storing the same data multiple times leads to several problems. By this technique, it controls the duplicate values performed on the applications. Restricting. Unauthorized access. When multiple users share a large database, it is likely that most users will not be authorized to access all information in the database. Databases can be used to provide persistent storage for program objects and data structures. This is one of the main reasons for object-oriented database systems. Database systems must provide capabilities for efficiently executing queries and updates. Because the database is typically stored on the disk, the DBMS must provide specialized data structures and search techniques to speed up disk search for the desired records. A DBMS must provide facilities for recovering from hardware or software failures. The backup and recovery subsystem of the DBMS is responsible for recovery. Because many types of users with varying levels of technical knowledge use a database, a DBMS should provide a variety of user interfaces. These include query languages for casual users, programming language interfaces for application programmers, forms and command codes for parametric users, and menu-driven interfaces and natural language interfaces for standalone users. A database may include numerous varieties of data that are interrelated in many ways. A DBMS must have the capability to represent a variety of complex relationships among the data, to define new relationships as they arise, and to retrieve and update related data easily and efficiently. Most database applications have certain integrity constraints that must hold for the data. A DBMS should provide capabilities for defining and enforcing these constraints. Some database systems provide capabilities for defining deduction rules for inferencing new information from the stored database facts. Such systems are called deductive database systems. Potential for enforcing standards. The database approach permits the DBA to define and enforce standards among database users in a large organization. This facilitates communication and cooperation among various departments, projects, and users within the organization. Standards can be defined for names and formats of data elements, display formats, report structures, terminology, and so on. Disadvantages. When information is centralized and is made available to users from remote locations, the possibilities of abuse are often more than in a conventional data processing system. Since the database is accessible to users remotely, adequate controls are needed to control users updating data and to control data quality. With increased number of users accessing data directly, there are enormous opportunities for users to damage the data. The main threat to data integrity comes from several different users attempting to update the same data at the same time. Centralizing all data of an enterprise in one database may mean that the database becomes an indispensable resource. Database models. A data model is a collection of concepts and rules for the description of the structure of the database. Structure of the database means the data types, the constraints, and the relationships for the description or storage of data. The network model and the hierarchical model are the predecessors of the relational model. They build upon individual data sets and are able to express hierarchical or network-like structures of the real world. The relational model is in today's DBMS most often implemented database model. It defines a database as a collection of tables, relations which contain all data. Object-oriented models define a database as a collection of objects with features and methods. Object-oriented models are very powerful, but also quite complex. With the relatively new object, relational database model is the widespread and simple relational database model extended by some basic object-oriented concepts. The three-schema architecture. The three-schema architecture is a convenient tool with which the user can visualize the schema levels in a database system. The three-level ANSI architecture has an important place in database technology development because it clearly separates the user's external level, the database's conceptual level, and the internal storage level for designing a database. It is very much applicable in the design of DBMSs even today. Let us study the three levels of DBMS. The internal level has an internal schema which describes the physical storage structure of the database. The internal schema uses a physical data model and describes the complete details of data storage and access paths for the database. The conceptual level has a conceptual schema which describes the structure of the whole database for a community of users. The external or view label includes a number of external schemas or user views. Each external schema describes the part of the database that a particular user group is interested in and hides the rest of the database from that user group. DBMS languages. Once the design of a database is completed and a DBMS is chosen to implement the database, the first step is to specify conceptual and internal schemas for the database and any mappings between the two. Data Definition Language (DDL). In many DBMSs, where no strict separation of levels is maintained, one language called the Data Definition Language (DDL) is used by the DBA and by database designers to define both schemas. The DBMS will have a DDL compiler whose function is to process DDL statements in order to identify descriptions of the schema constructs and to store the schema description in the DBMS catalog. For true three-schema architecture, we would need a third language, the View Definition Language (VDL), to specify user views and their mappings to the conceptual schema, but in most DBMSs, the DDL is used to define both conceptual and external schemas. Data Manipulation Language (DML). Once the database schemas are compiled and the database is populated with data, users must have some means to manipulate the database. Typical manipulations include retrieval, insertion, deletion, and modification of the data. The DBMS provides a set of operations or a language called the Data Manipulation Language (DML) for these purposes. Let us study the main types of DMLs. High level. A high level or non-procedural DML can be used on its own to specify complex database operations concisely. Many DBMSs allow high-level DML statements either to be entered interactively from a display monitor or terminal or to be embedded in a general-purpose programming language. Low-level language. A low-level or procedural DML must be embedded in a general-purpose programming language. This type of DML typically retrieves individual records or objects from the database and processes each separately. Storage management. The collection of data that makes up a computerized database must be stored physically on some computer storage medium. The DBMS software can then retrieve, update, and process this data as needed. Computer storage media form a storage hierarchy that includes two main categories. Primary storage. This category includes storage media that can be operated on directly by the computer's central processing unit (CPU), such as the computer's main memory and smaller but faster cache memories. Primary storage usually provides fast access to data but is of limited storage capacity. Secondary and tertiary storage. This category includes magnetic disks, optical disks, CD-ROMs, DVDs, and other similar storage media, and tapes. Hard disk drives are classified as secondary storage, whereas removable media such as optical disks and tapes are considered tertiary storage. Transaction. A transaction is an executing program that includes some database operations such as reading from the database or applying insertions, deletions, or updates to the database. At the end of the transaction, it must leave the database in a valid or consistent state that satisfies all the constraints specified on the database schema. Database administrators. In any organization where many people use the same resources, there is a need for a chief administrator to oversee and manage these resources. In a database environment, the primary resource is the database itself, and the secondary resource is the DBMS and related software. When a relational database is to be designed and developed as the requirements of the database and its processing becomes better understood, the data that we want to keep about each entity within an entity type is contained in attributes. An attribute is some quality about the entities that we are interested in and want to hold on the database. An attribute that is used to identify each entity from all the others in the entity type. This attribute is known as the primary key. The final element is the relationship type. Real-world entities have relationships between them and relationships between entities on the entity relationship. There can be more than one type of relationship between entities. Summary. Now in the end, let us summarize what we have learnt in this lecture. DBMSs are the technology tools that directly support managing organizational data. The DBMS provides a set of operations or a language called the Data Manipulation Language (DML) for these purposes. When multiple users share a large database, it is likely that most users will not be authorized to access all information in the database. Database systems must provide capabilities for efficiently executing queries and updates. Because the database is typically stored on disk, the DBMS must provide specialized data structures and search techniques to speed up disk search for the desired records.